Okay, hello, welcome back to the part 3 of the week 3. So we have covered the how we can manage the salaries and we talked about the insertion and deletion by using the salaries. And also we talked about their problems, these operations problems, and these operations take n retrievers to perform the insertion and deletion of a single element. So it's about single element, but we have to perform like n retrievers. That's the problem. And we talked about the linked list, and particularly the singly linked list. And we talked about the same operation, insert and delete. And we did a number of operations, but it really didn't depend on the number of the elements in the list. Rather, it depended on a constant number of retrievers. So this is equal to constant, okay? And what we are going to do in this part is that we are going to go over some variants of this singularly linked list to improve its utilization, okay? So there are problems of this simple singularly linked list, so people make a variant of this. So problems are often you can find a problem in the assumption. Consider this scenario. You are removing an unqualified customer from a credit card application list. So here, in this case, it's the record D. And the list starts from the head to tail, right? And A, B, C, D, E, F originally, and we want to remove D. And then what happens next is this. So we go through one by one, and you find an unqualified customer at the 10th node. Of course, here D is at the 4th node, but let's imagine that it's just ith node, right? And you want to remove the node, right? And then you need 9th node because that you need node pref. So this is ith node, and this I plus 1th node, and this I minus 1th node, okay? So you need this I minus 1th node, and you need this I plus 1th node. And what you have at this moment is ith node, right? And then if you didn't store the previous node, and then you have come to this part, and then what happens next is that you have to come to this part again. It means that it will be pretty handy to be able to go back to the previous node, right? So it will be much nicer to have a function to not just to go next, but just to go to the previous one, all right? So we need both functions at the same time, right? Many times. So eventually what you are doing is that n retrievers to remove a node in the singularly linked list, right? So it's really not such a good idea, because then you have this node, and then what you have to do is that you have to come through the search again, and in the worst case it will take n times, right? So it's not going to do it's not a good idea, right? So people add more information to the node to store reference to the previous nodes as well as the next node. It's called doubly linked list, okay? So how it is structured? So first variant is the doubly linked list, right? It is opposite to the singly linked list. And here, singularly linked list looks like this: head, A, B, and tail, right? It's just one-way iteration. And what we have in the doubly linked list is a special a node, a variant of singularly linked list node, right? How it is different? This is singly linked list node, and this is doubly linked list. How it is different? So first we have pref here, right? And previously we only had this part, right? And now we have this previous. A variable to hold a reference to its previous node. The other variable to hold a reference to its next node, we already had this. Hold a reference to its value object, we already had this. This is something that we have to add more. So we have to add one more reference to the node, and this allows users to navigate through both ways in the list. So in the UML class diagram, you will see this doubly linked list node, right? And then you have three variables: value, and next, and right? Previous node. And then you will have get next, get previous, get value, and so forth in this double linked list. Okay, so it's pretty easy alternation. It's pretty easy variation, and then what you get is that you can do this two-way search, and your operations would be much easier, right? So that's good. Okay, so but the insertion and deletion would be little different from the singly linked list. Of course, it's not that different. Okay, let's look at this. So it's similar to the insertion procedures in the singly linked list. Okay, this time what you have to do is that you have to update two references opposed to the one reference in singly linked list. Okay, with an assumption that you have this node pref, right? You have this node pref, right? And then you want to add this node new. First you have to you store a node or a node next pointed by a reference from node pref's node next member variable. So you have to store this somewhere, and then second you change a reference from node pref's next to the node new. So you add this point here, and then third you change a reference from node new's node pref to the node pref. So you update this reference, and fourth you change the reference from node new's node next to the node really next. This is something that you already stored previously, which is by this operation, right? By this operation, you already stored this node pref's next, node next somewhere, right? And then what you are going to do is that node next is updated, and then finally node next node pref is going to be node new, like this. Okay, and then you have this nice chain of going through this way as well as going through this way, right? So this is how you can do the insertion operation in doubly linked list. How about the delete operation? Very similar, again very similar to the delete operation in the singly linked list. Now you have to update two references for each node. Unlike you already had to do to update just one reference for each node in the previous case. But in the double linked list, what you have is that you have two variables to hold references, previous one and the previous node and the next node. So you have to do the operation two times. Okay, so with an assumption that you have a reference to the node pref that you want to remove, node next. So this is the one that you want to remove. Okay, and first what you're going to do is that you retrieve node next by using the node pref. So it's going to be node pref dot get next, and then dot get next. Okay, so get next, and then get next is gives you this one. All right, you already have this one, and then so that's the first of this first operation. But you had to perform like two get next, so it's two operations. And then what you have to do is that you change a reference from the node prev node next to the node next. So you create this reference, and then third you change your reference from node next to the node prev to the node prev, right? You update this reference, right? And then this node will be removed because there is this node remove is going to be removed because there is no reference to pointing at node remove. Okay. So after this operation, what you have is that you have this nice chain, right? And then come back here and goes like this, and then again like this, and then like this. Okay. So you have nicely chained doubly linked list.